Welcome to the first unit in the screencasted version of the programming part of the machine learning lab. You might already have seen the method exercises. We also have programming exercises, which are designed to provide you with hands-on experience of implementing all the different mathematical concepts that you might encounter in the lecture. This lab will be done in Python, and we will basically from the ground up implement our own machine learning algorithms for a selection of methods that are presented in the lecture. This first unit is about setting up your local environment so that you can follow along future exercises. So I will show you in this video on how to set up a virtual environment, how to install all the different Python packages that we are going to need throughout the semester, and give you a few pointers on where to go next and what kind of Python knowledge we already expect from you to follow along successfully throughout the semester. So first up, what is a virtual environment? A virtual environment sort of encapsulates whatever you're doing in Python into a local folder, and you can then install Python packages without messing with your global system-wide Python installation. This has a few benefits. For example, you cannot run into the issues of having conflicting package versions, and also allows you to basically remove the packages cleanly whenever you don't want them anymore. You can just delete the virtual environment. There are different options of creating virtual environments. The one we are going to demonstrate things with in this lecture is venv. If you have experience in any other package manager, for example, PyEnv or Conda, feel free to use the one you like the most. However, whatever we demonstrate will be done in venv. Conda also gets a honorable mention here because if you're not comfortable yet working with the command line interface, Conda is one of the package managers that has a graphical user interface. So if you find that easier, you can also always use Conda. Okay, before we actually create a virtual environment, we have two important notes. The first one is that you need, of course, Python installed, and you can check this by just typing python 3 -- version. And in my case, this will tell me that I have Python 3.9.13, which is also the Python version that we expect you to run. You should be fine with most other Python 3 versions, be it 3.6, 3.10 or whatever. But there are some little bugs that might be introduced by using different ones. So to be safe, you can use Python 3.9 and everything should work out of the box. If you don't have Python currently installed, you can either download it from the Python website. So if you go to python.org and then downloads, you will find a list of specific releases. For example, the one I'm using is this one right here. Download this, install it as documented here, and you are ready to go. Of course, if you work on a Unix-based system, any package manager, apt-get, pacman, whatever you want to use should also give you the option to directly install a specific version of Python. While on the topic of Linux, everything we do in this lab will be Unix-based. So I will demonstrate things in my environment, which is macOS, but everything I do should work out of the box on Linux too. If you're running Windows, you might need to adapt the shell commands that I'm running to Windows syntax, or install the Windows subsystem for Linux, and then everything should work exactly the same. We explicitly do this on Unix-based environments because once you do machine learning at a scale that goes beyond your laptop and you need to use cluster environments and stuff like this, you will inevitably run into Linux-based systems because every machine learning cluster, at least the ones that I'm familiar with, run on a Unix-based operating system. So you can take this opportunity if you have not already to get some experience with Linux-based shell commands. Okay, with that out of the way, let's create our environment. So as I mentioned, we are going to use venv. You can follow the installation instructions. And the first thing is to type Python -m. The -m tells Python that I want to execute a certain package, in our case the venv package, which should ship with most, at least with this version and most other modern Python versions. If for some reason this produces an error, have a look at these linked installation instructions here to see if you might need to install this venv package manually. This expects one argument, which is the path to the directory that you want to save your venv under. I'm just going to name it venv. You can also name it ML lecture, or what other name you might want to come up with. So once you execute this, you can see that it now created this folder right here. You can ignore this folder, actually. This is from a previous recording. This ML lecture folder here now contains our virtual environment, and we can have a short look inside there. There are a couple of subfolders, importantly bin and lib, which is where your Python packages that you install now will be installed at. So whenever you don't want this Python installation anymore, you can just, as demonstrated here, remove the whole folder and any trace of these Python packages is gone from your computer, which is a really clean and quick way to uninstall Python packages. As of now, this environment is present in this folder, but it's not currently activated. So we need to run this down here to activate the environment. So I'm going to type source. And again, I think the command is not named source on Windows. So have a look on how to activate your environment if you're working on Windows. So I named it ML lecture. And inside there's the bin folder, which contains the activate binary. And if I activate that, I can see that I now have this prefix here, which tells me that this shell session is currently running inside this ML lecture virtual environment. It's important to note here that this is only affecting the current shell session. So if I create a new shell session, for example, by creating a new tab, this, as you can see, does not have the prefix. So whatever you do in here will affect your global installation. Whatever you do in here where the environment is active will affect only the local environment. Okay, now that we have this virtual environment activated, we can install Python packages without interfering with your system installation. There are two ways of doing this. We supply what's called a requirements file. It's on a website, you can download it. I'm going to demonstrate the explicit way and talk a bit about what different packages are contained in this requirements.txt. Before we do that, we upgrade pip. Pip is our package manager for Python packages. So I'm just going to quickly run python -m pip install and upgrade pip just so that I have the newest version available. And you can see that it upgraded from the 22.1 that I was previously running to now 22.2. Again, the version here might not matter in the end, but it's just good practice to have everything at the newest version. I now have pip available on my command line, so I can go ahead and either do the quick way, which is install -r requirements, which I won't do now because I don't have the requirements file inside here, because I want to do the explicit way, and you can just list the packages that you want to install. In our case, it would be NumPy, the most important one. Again, NumPy is a numerical package for Python. Apart from NumPy, we are also going to use Jupyter, which is the programming environment where the notebooks that we will supply you with can be run in. I would also advise you to install not Jupyter, but JupyterLab, which gives you a slightly different environment, but I think it's a better one. So yeah, install JupyterLab. Then we are going to install sklearn. sklearn is a reference implementation of many machine learning algorithms, and the ones that we will program in this lab could be directly compared to the sklearn reference to see if they produce the same results, if we did correctly. We also might want to look at some plots of data of loss functions and stuff like this. So matplotlib is advisable to install, and to get a nicely formatted view of some tabular data and import data quickly, pandas is also advisable. But you don't strictly need that. So I'm just going to hit enter, and this might now take a while to download all the different packages depending on your internet connection and computer speed. This can take a couple of minutes. While this is installing for me, I will jump ahead to explain what Jupyter is. So normally Python is not an interactive environment, right? You have a Python file, you execute that, and it will step through your Python commands in your Python file one by one, line by line, and it's sort of linear. And this is not really what you need in most settings for machine learning, where you want to, in between, view what your data looks like, maybe log something to standard out, go back, change variable, try again. And that's where Jupyter comes in really handy. So to start up a Jupyter instance, you can just type Jupyter Lab on your command line, and this will now start up a web server and automatically open in your browser. If it does not automatically open, there are these two links here. One is localhost, one is an explicit IP address. Be sure to copy the whole link because this token part is important into your web browser of choice and open it there, and then you should see this view right here. So on the left, we have a file browser where I can see the contents of my folder. We see the ML lecture, which is our virtual environment directory, and we can see the PDF guide that I showed previously, and also two Python notebooks that I will talk about in a second. There are also different options here. You can create a new notebook, you can create a new terminal. So this would give me a terminal window inside here. If I don't have access to my actual CLI. But most importantly, I can open notebooks. So if you download one of the notebooks from our website, one of the exercises, you can just place it in the folder that Jupyter has access to and open them by double-clicking. And depending on the size of the notebook, this might take a little while because it needs to parse the file. But now you can see what actually is inside these notebook files. For the first week, or for this first session rather, we have these two files only. I will not talk about them in detail because we expect you to already have some proficiency in Python coming into this lecture. We just don't have the time to teach you Python. And since most of you are already in a higher semester and might already have taken, for example, Modellierung und Programmierung 2, I think, has a Python part, we expect you that this shouldn't be new. But still, you can step through this notebook and have a look at the different features of the Python language, maybe also as a refresher if you haven't used Python in a while, to make sure that you know all how this works, so we can rely on it in the coming lectures. I will not talk about this in detail, I'll just quickly scroll over it. And the second notebook we supply is about the features of Jupyter. Again, I will not go into detail here. I will just very quickly tell you how a Jupyter Notebook itself is organized. So each Jupyter Notebook consists of cells, and cells might either contain code or documentation. You can switch the type up here. This is currently code, so I can switch it to Markdown to just type in Markdown. And when I execute the cell, either using Shift-Enter or using this little execute button up here, it will render the Markdown. If it's a code cell which contains Python, it will execute whatever code is in there. So I can set the variable A to 5. And on each code cell, you see this little index right here. this indicates the order of execution. So if I have a second code cell here, which now gets a 2 because it's a second cell executed. If I execute this again, it now gets a 3 because it's a third sort of executed line. And this is already demonstrates a nice feature of Jupyter Notebooks, is that your program should be, but not necessarily has to be, linear. So I can set A to 7 down here, switch up to the cell up here, and 7 is now, A is now 7. And so if you, for example, machine learning contexts work with lots of data and you modify this data, you can just create another cell, call whatever your data variables, have a look at it in a very quick and interactive fashion. Also note that only the last line of each cell, if it produces an output, will get printed. So if I put b equals, I don't know, 9 in here, this will first produce an error because, as you can see, this cell right here, because it's orange, was not executed after being modified. So my Python kernel does not yet know about the b variable. I need to execute this once. And now it will output the last line, which is b. However, now I can also say the a value. So this is just a very basic rundown of how Jupyter works, and there are lots more features in Jupyter that you can have a look at in the second notebook. One very handy feature is that whenever you prepend a code cell or a line in a code cell with an exclamation mark, it will be run as a shell command instead of a Python command. But there are many other different features that I advise you to have a short look at. We will not make extensive use of them, but they're just generally good to know. Okay, that about concludes this first video cast for the programming part. Again, have a look through both of the Python and the Jupyter Notebook on the website to make sure that you are up to speed regarding our requirements in proficiency for Python. And then you are ready to jump into the next programming exercise for this week, which will give a short introduction into NumPy.